Hello, and thank you for joining us today for the HPCC Systems Community Tech Talks. These are community tech talks for the community, by the community. All right. Trish, I'm having some technical difficulties. If you would please forward the slides, that would be awesome. All right. So welcome, everyone. We're thrilled that you could join us today. First thing we'd like to do is go through some housekeeping. So we invite you to share. Please let other people know that you're here with us with the hashtag HPCC Systems Tech Talks. And please also ask questions. We really invite your questions. I think they make the talks definitely more interesting. And we will answer as many questions as we can following each speaker. Also, please look for the polls at the bottom of your screen and exit full screen mode if for some reason you can't see those. We also welcome your feedback. Please do rate us before you leave today and visit our blogs for more information after the event. And if you'd like to be one of our featured speakers, we certainly would love to hear from you. Let us know. Email us at techtalks@hpccsystems.com. All right. So moving on to our community announcements, usually Flavio handles this part of the call, and he's traveling today, so you get to hear me talk a little bit more. We've got my picture there, so I'm the shorter, cuter version of Flavio today. We're really excited that the HPCC Systems platform, we have another update. 6.4.14 is our latest gold version. You can also see the changelog for details. You can go to our download page on the website to download that. Our summer internship program, we have 10 interns this year. And we will have more details on those students and those projects coming up in May. So Lorraine Chapman will be joining us, and she'll have all sorts of great information there. Recent blogs, we've got the Fly on the Wall Developer Offsite Meeting blog also by Lorraine Chapman. These are great blogs. They give you some insight into what our platform team is thinking. We also have the software architectural design and how to implement it in ECL. And we've got a blog on HPCC Systems and how we are committed to funding the planting of 10,000 trees. And that's a blog by Flavio, and it talks a little bit about the background of why we're doing this. We're also very excited to announce that we've got our date set for the HPCC Systems Summit Community Day, which will be happening October 8th through 9th here in Atlanta. And this year we've got 2 pre-event workshops. One of them is more on the beginning side of the house for people who are new to HPCC Systems. And then we have an advanced workshop that Arjuna Chawla will be leading. So that'll be a great addition. And you can attend both of those workshops all within the same day. So one will be in the morning and one will be in the afternoon. We also have our poster competition going on again this year. We welcome all of the students out there who are interested in submitting a poster. We've got some excellent prizes, and we would love to have as many people participate as we can. Those are always one of the top draws of our community day. We also have sponsorship packages. So if your company would like to sponsor us, please do let us know. The information is available on the website. And we also have our call for presentations and poster abstracts going on right now. If you're interested, again, just reach out to us. You can reach out to us at the same Tech Talks at hpccsystems.com or visit our webpage. It's hpccsystems.com/HPSummit2018. All right, so moving on to our 10K Trees campaign. We touched on this earlier when we talked about the blog post, but we're definitely doing a big push between March 21st and April 22nd, and we're thrilled that the National Forest Foundation has enabled us to continue this throughout the year. So it'll be out there and it'll be available, and we really welcome you to help us plant these trees. This is our way of getting to know the people within our community. As an open source platform, we don't necessarily know who you are, but we'd love to know who's working on our platform. We don't have a sales team, and so I promise you that nobody will contact you. The worst thing will happen is that you might get a newsletter. So we would absolutely love to have your participation. All right, moving on to our speakers for today. We're thrilled to have Matthew Upchurch Butler joining us. Matthew is a senior at Kennesaw State University. He's majoring in information technology with a concentration in information security and assurance. We first met Matt a year ago at Kennesaw State's hackathon, where outside companies would come in with real-world problems. And we came in as LexisNexis, and Matt partnered with the team working on HPCC systems and was a third-place winner. So he is currently an intern here at LexisNexis, and he's working with us at HPCC Systems to develop a standard math library for the company's enterprise control language. Matt is going to be talking about some of what he worked on with the hackathon, and that is the future of automotive telemetry. So assessing autonomous vehicle risk implications using simulated data. And while I think a few years ago, we all thought, oh, autonomous vehicles are a little bit far-fetched, but we're living in this reality today. And Matt's going to talk to us a little bit about how this new technology will affect today's modern societal and industrial norms. We also have Russ Whitehead, so he's an architect here at LexisNexis. And he's a software architect and has a BS degree in computer science from the University of Florida and an MBA from the University of Miami. He's worked with operating systems development, network management, and voice recognition. One of the things that we love about Russ is that he works on the security, which is just so very important to us. He works on the security framework. And he's going to be talking to us about developing a custom pluggable HPCC security manager. And he'll be talking about how a software developer can implement the HPCC system security manager interface in order to create a custom security manager that can then be plugged into the HPCC systems configuration. We're really glad Russ is joining us. I think we had a question a few tech talks ago about security, and Russ was very generous to agree to come in today. We have another person out today, actually two people. So we usually have Bob Foreman and Richard Taylor joining us to talk about what they hear in the HPCC systems community and to share some of those training tips with us. And both of those gentlemen are traveling today, and so Craig, again, has been very generous to join us to give us our tip. He's a consulting software engineer. He's been with LexisNexis for 26 years, and for the past 20 years, he's worked with object-oriented programming in the Windows environment. He's new to HPCC systems and ECL, but he's got 15 years of experience teaching software concepts at the college level. So we're thrilled that he can join us today, and he's going to be talking to us about understanding the ECL watch graphs. So we'll be looking at the features and the uses of work unit graphing functionality, and this is the functionality that is built into the ECL watch application. So those are our speakers. And with that, I'm going to go ahead and turn it over to Matt. It's all yours, Matt.
Okay. Thanks so much, Jessica. That was just really warm welcome. You made me feel good about myself. Hey, everybody. My name is Matthew Upchurch Butler. I am a senior at Kennesaw State University, as Jessica mentioned, currently interning with LexisNexis HPCC Systems. And I just want to briefly say just thank you and acknowledge the partners, Trish, and everyone else involved just for inviting me on here. I appreciate the opportunity. So today's topic. The future of automotive telemetry, assessing autonomous vehicle risk implications using simulated data. I want to begin with a definition of telemetry. Telemetry is simply the process of recording and transmitting the reading of an instrument. So we're going to look at how that applies to autonomous vehicles. Okay, so before we begin, quick poll. Based on what you have already experienced and just your own kind of opinion, how dangerous do you think self-driving vehicles are when compared to human drivers? I want you to take a moment, think about that, answer the poll question, and we will review this at the end of the presentation. Okay, so quick outline of what we'll talk about. I want to first begin why this matters. I always think it's important to understand the relevance of the topic. I want to go into a little bit of the background about the specifics of how I was able to put this together and the foundation for some of the facts and figures I'm going to give you. Talk about the risk factors, and in this section we'll look a little bit about how this affects different insurers, auto insurers, simulated data analysis, just that, applications, some few uses of this, and finally some dangers of it. Okay, so why does this matter? Why talk about self-driving cars, autonomous vehicles? Well, industry experts predict that by 2024, which is just 6 years from now, the majority of travel in major cities will be done by on-demand autonomous vehicles. And furthermore, by 2035, hailing an autonomous vehicle for transport will be the new norm. So think about how this will replace taxis in a major city like New York or LA or something like that. And this is from a KPMG article listed at the bottom of the slide there. They're predicting that also autonomous vehicles could shrink the automotive industry by 71% or $137 billion over the next 30 years. And I can imagine if there are many insurance agents like the ones that I've dealt with, they'd be upset about losing $137 billion. 21 states have already passed or introduced bills related to self-driving vehicles as well, so there is also some legal implications. Okay, a little bit of background. The Society of Automotive Engineers in 2016 released a standard classification for the features of an autonomous vehicle, listed from SAE Level 1, driver assistance, up to SAE Level 5, full automation. Most modern vehicles that are being created right now are typically Level 2, like the newer Teslas are Level 2, just for perspective on where we are right now. Levels 3, 4, and 5 aren't readily available at this point in time. They're kind of still in testing phases, so we're not quite at that point yet. But a little bit about the background on each one. Driver assistance is pretty common even now. Vehicles can essentially control their own speed. Some can even control their lateral movement left to right, but not both at the same time. This is kind of like cruise control. Most cars already have this. It's been around for a while. We're used to it. 2 is kind of the newer one. This is kind of where we are now. The vehicle can control its own speed and lateral direction at the same time. So it can speed up, it can slow down, and it can turn, which is a lot of what we see nowadays being marketed as autonomous or self-driving vehicles. The third category, conditional automation. The automated system controls the full domain of dynamic driving tasks, which means it does all of the important things, reacting, turning, adjusting, that kind of thing, with the condition that a fallback-ready user is receptive for requests to intervene if and when it's necessary. There has to be a person behind the wheel, prepared, actively engaged to step in if there's a system failure or an emergency or anything else. That is a condition of that level. The fourth level, high automation, in which the automated system controls all of the driving tasks and fallback controls without expecting a user to be ready to intervene. So you don't need a person at this level to react behind the wheel. However, these can only operate within a specific set of limitations, and those limitations can be based on factors like geography, traffic density at the time, speed, roadway conditions, etc. So only in the right situations will this allow you to not pay attention to the road, basically. And then the last one, full automation. It's essentially the same as level 4, but without those limitations. Anywhere you are, wherever your car is, road condition doesn't matter. You can be driving across the desert somewhere. Your vehicle's still going to be able to drive itself. So again, where we are right now is about level 2 with the newer vehicles. We've still got quite a ways to go, but that is the standard definition. This also is used by the U.S. Department of Transportation. SAE also predicts that 18 million level 4 and 5 vehicles will be sold by the end of the year 2035. So this is something that's coming soon. Okay, and a few more background assumptions. For the rest of the presentation will be based on the assumption that I'm talking about the years 2025 to 2030. The saturation of autonomy levels is saying what percentage of cars on the road fit into this autonomy level. So again, by that same time period, I'm saying about 47% of the vehicles on the road will be L5, plus the 30% from L4, 77% for the higher 2, 87% for level 3 to 5, which we haven't got to just yet. So things are going to move fairly quickly. Also, vehicle-to-vehicle communication and vehicle-to-infrastructure communication. What that means is, by this point in time, 100% of the vehicles will be able to communicate with each other. They'll be able to relate to where one is by position. They'll be able to relate to reaction times and respond to those kind of things too. Maybe somebody cuts you over and you need to be prepared for that, or someone signals they need to get over, so your vehicle knows it has to slow down just enough for them to be able to come in, or something like that. And lastly, vehicle-to-infrastructure. How your vehicle actually communicates with the infrastructure around you. Are there sensors in the roadways? Are there sensors in the lights? How does the crosswalk button function to let people walk by? When do the lights change? That kind of thing. And that was only at 80%, factoring in it taking a little bit longer to actually develop the physical infrastructure of a city as it would be to make a new feature in a vehicle. All right. And the last little bit of my background here, the data collection aspect of it. So in order for autonomous vehicles to operate properly, they'll need an interface. And part of that interface is going to include a system to track, monitor, and log the important data points from each vehicle. Now, this kind of thing already exists. Progressive Snapshot is the one that first came to mind for me because that's what I use. Allstate, State Farm, Nationwide, and a lot of others have similar devices. You plug it into your car, and it can monitor everything from the time of day that you start your car to how hard you brake at an intersection to a sudden turn and a lot of other things. So data collection in reality and autonomous vehicles during this time period that I'm referencing will already have that built in. But if it doesn't, it could easily be added, and they can easily gain that additional functionality. So lastly, for my example here in this presentation, a simulated data set is going to be used as opposed to the real one that we use. Okay, and regarding the data set again, it's going to be over a 400 square kilometer area in the city of Cologne, Germany. The simulation is going to take place over a 24-hour period. It's a single day, comprised over 700,000 individual data points, and among those data points are the X and Y coordinate, vehicle speed in meters per second, individual vehicle IDs, and also the timestamp of the data. And a couple other things to note, just to make the simulation a little easier to work with. I assume the constant speed of 100 kilometers per hour, and a trip is defined as a vehicle starting from the speed of 0 and ending at a speed of 0. So it's quite likely for a vehicle to take many trips before it reaches its final destination. So just a little bit about background there. Okay, so an important part of risk is or in developing risk is understanding what criteria make something risky. So in terms of vehicle, what traits do we look for in driving that are risky? What things do we consider? Distance traveled, the average number of trips, instances of speeding, location, traffic density, which is an important one. We'll look at that on the next slide. Time of travel, more things like that. So these are all things that I wanted to consider and be able to answer, statistically speaking, based on the data set. What conclusions can we make? How can we draw the line there? Also on the right-hand side of the screen there is a little bit of the ECL coding I did to do this. I believe that example is distance of an individual vehicle during a certain time period. I believe it was like 3 to 4 p.m. or something. How far did a car drive? But you can get really specific using the HPCC systems ECL language, and that's a little bit of the code there for those who are code savvy. Okay, and this actually goes into my simulated data set. So what we're looking at here is just a screen cap of Google Maps of the city of Cologne, Germany. Now, one of the first things I wanted to consider when looking at the risk implications of a vehicle, any vehicle, is traffic density. I live in Atlanta, so traffic here is legendary. You have to factor it in. You really do. It's also a lot riskier. You're much more likely to see an accident or have an accident yourself in 5 o'clock traffic in the middle of downtown than you would at, I don't know, maybe 10:30 on the outskirts of the city. So there's going to be a big difference there. So what I wanted to do was take an instantaneous snapshot at any given point in time. Where are all of the vehicles? And I was actually able to do that and map that out as an overlay and overlay it onto this Google Maps. Now, it's not a one-to-one exact ratio, but I think you'll still get the effect here. So I wanted to look for the instantaneous traffic density at one point in time. And that transition there, that is actually, what we're looking at now is the actual graph of an instantaneous traffic density. I believe this was at 5 p.m., so this is rush hour traffic here. And it would be easy for an insurer to look at something like this and say, well, your vehicle spent the most amount of time right in the heart of what we're looking at here. You're right in downtown. You're putting yourself in a lot riskier situation. There are a lot more vehicles around you. So obviously, you're going to have a higher premium. That opposed to someone whose vehicle spend the majority of the time in the upper left or the lower right-hand side of this graph here. Less vehicles, less density, less risk, more than likely less premium. So just a few other questions I wanted to kind of pose for the audience, just for you guys to kind of think about. What insight does this data provide? What kind of conclusions can we draw by being able to track these different data points? You know, what other relationships can there be between those data points? What else is important? It's kind of like advanced analytics, if anyone's an NBA fan. Also, what benefit would this provide? Could we see this becoming something that can really be used positively and make some real-world impacts? And lastly, assuming that we will be able to determine vehicle-specific risk from data collection, how will that affect the insurance industry? So how is insurance going to react to this? We already know they're posed to lose $137 billion. Okay, now I want to talk a little bit about the applications of it. Now, I envision autonomous vehicles having a graphical user interface, a GUI. And this GUI will be integrated into an insurance system and provide vehicle-specific and possibly even driver-specific behavioral information. And I wanted to just explain that architecture a little bit down there. I'm sorry, that was my smart assistant interrupting. So, inside the graphical user interface on the insurer's backhand side of it, they would have the option to determine risk by either an individual or by a vehicle. If they chose vehicle, they would be able to look up the VIN number, the firmware version, run that through a database like HPTC System Store, and then you'll be able to also calculate and factor in maintenance records, accident history, things like that. All of those listed at the bottom there. You'll be able to calculate those and run that back through the store and come up with a risk that way and return that through the GUI. You could also do it on an individual basis where you look at things like name, address, date of birth, calculated by age, driving history, gender, and things like that, and return that back to the GUI. And that's actually a way where you'll be able to kind of use this this interface. That's kind of how it will flow. Now, one other thing I wanted to note about the individual aspect of it, I think it would be kind of a cool feature if an autonomous vehicle was able to calculate risk based on a individual. So not just, not just your household, not just that, you have a 15-year-old kid in your house or a 16-year-old who's learning how to drive, but that also, they only drive 1 hour a week, or they only drive 12 hours a week. Now, those people who, with the kids driving at different amounts, shouldn't necessarily have the same rate, I don't think anyway. So what I propose is a way to have a key, maybe like a bio key or a pin or a fingerprint or a retina scan, that kind of thing, and you can know exactly who is behind the wheel, not just who's in the house, and not just make a general base premium based on everyone in your home, but specifically who was behind the wheel most often. And if it's mom 90% of the time, it shouldn't be the same as if it was mom 40% of the time and it was dad the other 60, but dad has, 9 accidents in the last 2 years or something like that. I think that kind of thing should make a difference. So I wanted to mention that. I think that would be a nice feature to add there. Okay, one more application I wanted to look at here. I also envision these systems being able to make a choice about not just where you want to go from point A to point B, but how you get there. And a lot of driving applications now even already have that functionality to give you multiple routes to choose from when deciding to go from point A to point B. So this is going to have the same kind of thing. So in this example, we're going from point A on the right near Sandy Springs to point B on the left at Lucky Drive. Now look at the path we're taking. We're avoiding major interstates. We're going over a bridge. We're going around, looks like some grass area there. These are back roads. These are roads that are probably going to be a little bit less developed, a little bit more hazardous, a little bit more risk. There are probably less vehicles on this road that have vehicle-to-vehicle communication or vehicle-to-infrastructure communication. The infrastructure may not be there just yet. All these different factors make it a little bit more of a riskier option in the next slide we'll look at in a moment here. But the drive only takes you 16 minutes to get from point A to point B versus this option. The same 2 points near Sandy Springs to Lucky Drive, with the difference being now we're taking major roads. Now we're on the interstate. We're around other cars that have vehicle-to-vehicle. The infrastructure was developed first because it is an interstate. The government, got behind it and developed that infrastructure first. Whatever the case may be, this is now a safer trip. So it has a lower risk factor. The risk factor on this one was 64. The one on the previous slide was a 75. And those numbers are really just arbitrary, but I chose them just to make the point that there is a difference in terms of risk factors, and some will be given higher factors versus some with other lower ones. Now, the downside to this one, yeah, it's safer, but it takes 7 minutes more. So as a driver, you get to choose. Do you want to take the course that'll get you there in 16 minutes? That might be a little bit riskier. Or do you want to choose the course that'll take you 23 minutes, but it's a little bit safer? And that choice that you make is going to return a ratio. And that ratio will also help insurers calculate risk. So it's going to work like this. You'll take the risk value of a route that you chose over the optimal route, the safest route. So in these previous two examples, the safest option had a risk factor of 64. Now, had I chosen the first option, it was 75. So 75 over 64 is something like 1.17, 1.18, versus the safest option, which would be 64 over 64. The one I chose, 64 over the optimal 64, returns a ratio of 1. So I envision that ratio. This may be some of my math coming out now. I envision that ratio working like this. An insurer will be able to say, the closer you get to a ratio of 1, the lower risk taker you are. You make safer decisions, and we know that. And again, you can factor this in based on the individual, or you can factor this in based on any individual in your home. So you can know that when mom drives, her insurance is always lower. But if dad's behind the wheel, he might have doubled it or something like that. And they'll be able to say, based on that ratio, you fall within this bracket. You fall within this column that we have a standard rate for. And I think that would be a pretty natural, a pretty easy way to apply an application there. So I think that's one good point to mention. Also, beyond just consumer traffic, beyond just the traffic that everyday users do, just us, autonomous vehicles have also shown the potential to revolutionize many other aspects. Ride-hailing, Uber and Lyft. The statistic earlier already says by the end of 2035, they're expecting the majority of traffic to be done by on-demand vehicles like that, where you can just stick your hand up and then the car comes over and then you're just on your way. Industrial transport. Walmart has already pre-ordered 15 autonomous semi-trucks from Tesla. That's a lot, and they're expensive, and they're really pushing behind that. So Walmart's really believing in that potential there, and it makes sense because trucks could run around the clock. The companies wouldn't need to set aside time for drivers to rest. They would be able to constantly run, and this would mean that goods could be transported faster and cheaper. They may end up, having some ethical dilemmas with, maybe needing less drivers or having to make some cuts that way, but a lot of times businesses tend to do what's best for their business, and I can definitely see a profitable situation there. And also more efficient parking structures, design and use. Just that. You would be able, if vehicles can drive themselves, they can be super efficient. They can use the optimal amount of space. They can know, I don't need that much clearance on that side that a human might feel like they need. I know that the vehicle has this dimensions, and it can just make design a lot easier to use there. Okay, so one last thing I wanted to mention, and this is coming to the end of my presentation here. There are a lot of positives to autonomous vehicles. I see this as the future. I think it's unavoidable. I think that in just a few years, we'll be looking back thinking about, you remember when, we were just having that conversation, you remember when it was a joke to have self-driving cars? Kind of like we say, you remember when it was a joke to have a watch that could talk to you? And now, how many people have an Apple Watch on right now? So it's coming fast. We're closer to the year 2035 than we are to 2000 at this point. So this is on the way. But despite all the positives there are some dangers. There are some real concerns with autonomous vehicles. In just March of this year, a self-driving Uber vehicle struck and killed a pedestrian in Arizona. It was a woman walking on the side of the road. It was the first death caused by an autonomous vehicle. Now, a Florida man was killed in a Tesla crash in 2016. However, it was determined that he was extremely negligent. He did not respond to any request to intervene. I think he had fallen asleep behind the wheel, and it was not a vehicle malfunction that caused his death. So though there was a loss of life there, this goes back to my earlier slide talking about the levels of autonomy, and that people think we're a lot further than what we really are right now. So it was ultimately determined that that was not the actual vehicle's fault itself. Okay, and lastly, just closing out here, I want to have a quick poll with you guys. One more. Considering the potential risks and the potential benefits of autonomous vehicles, would you personally be hesitant to use this new technology? Take a moment to think on that, and we will again review the poll answers in just a second.
Okay.
All right. I want to give a quick acknowledgement to my colleagues on the left and also the HPCC systems team on the right. You guys all rock. I appreciate your help so much, and I just want to make sure I acknowledge each one if y'all want to give you your moment. All right, and now we open it up for questions.
All right, Matt, thank you so much. So for everyone, I would really encourage you to answer some questions. This is such an interesting topic. I'm sure there are a lot of questions out there. So please do feel free to send us your questions. And while you're doing that and while you're responding to the poll, we're going to go ahead and take a peek at the results of our first poll. So the question was, how dangerous do you think self-driving vehicles are when compared to human drivers? So 25% of you thought it was much less dangerous, and 37% said a little less dangerous. So that's definitely over, I guess, that's about 62%, so that's quite a bit. 18% thought about the same. 12% said it's a little bit more dangerous, and 6% of you think it's much more dangerous. So this will certainly be interesting to see over time. All right, Matt, if you're ready, we're going to go ahead and head to the questions. It looks like we've got a few good ones here. So our first one is, how do you think using autonomous vehicles will impact human behavior society?
Okay. I think that they're going to make us, I think, move faster. I think that they'll kind of speed things up. It'll be a lot easier to get around. It'll be a lot easier to make dynamic positioning moves, I guess, so to speak. I also think they have a potential risk to make us lazy. I think as humans, we tend to rely on automated systems. We tend to just trust things to get done, and we want to forget about them. And sometimes it makes us lazy. I remember watching SportsCenter a couple of days ago, and someone said the same thing about a football player, or about an aspect of football, rather. But we tend to, skills that we don't use, or skills that we allow a computer or something else to do for us, we tend to neglect, and those tend to get rusty. So I think it potentially could, make humans a lot lazier, and it can make humans kind of forget how to drive too. So I think we need to be careful with that. I think we shouldn't go overboard with it, like anything.
And a follow-up to that, Matt, how dangerous do you think self-driving vehicles are when compared to human drivers?
I think that based on the research I've done, I know that there are, statistically speaking, less risk involved in autonomous vehicles. So the numbers show that, and the math is there, and the statistics are there to prove that. So in that sense, I think they're less dangerous. Also, I think that, I was thinking about this as I was driving earlier, as humans, if we trust something, if we're giving a machine the authority to regulate a process, we need to make sure that process is executed every time. If you had a calculator that didn't always calculate 2 + 2 = 4, it only did it 90% of the time, is that still the calculator that you want? So I think that the numbers are there. It is less dangerous. I do believe statistically it is less dangerous, but how much risk are we willing to accept as people from a computerized process? And I think that's an important question to kind of consider on your own as a person.
All right, thank you. All right, here's another question. Legally speaking, how has the government responded to the use and growth of the autonomous vehicle sector?
Well, I think there are a couple of different ways to kind of look at that one. Earlier in the presentation, I did mention that there were 21 states that have already passed or introduced some kind of legislation regarding automotive vehicles. 21 is less than that, so there's 29 others that haven't. Is that right? Yeah. That haven't yet. So the majority of states still have no regulation about this at all. In fact, states like Arizona, where the woman was killed at, have such loose regulation regarding it that is the state that's chosen by these big companies to do their testing in. Uber is there, Lyft is there, Google was there. Lots of companies test there because of the light and legal restrictions there. So federally, I don't think we've really I don't think we've really done much there in that regard just yet. I think that's on the way soon, but I don't think there is too much going on federally right now that I think has serious implications versus these different states. Different states have different rules, and some of them are strict, and some of them do factor in the protection of others, and some factor that in too, but maybe to a little bit less extent, or maybe it's a little bit more beneficial from a financial sense or something like that. So I think that government in that situation, it plays a couple of different roles, but overall, it's a state-by-state thing. And as long as it's a state-by-state thing, businesses can, make the choice that they want to make about where they want to be at. And I think that's going to determine a lot of things in the near future.
All right, wonderful. It looks like we have the last question, and this one looks like it's related to the profile overview we did. Is the work that you're doing with the Math Library similar to anything that you've done in the past? And we are thrilled to have you here as an intern, by the way, working on this project.
Well, thank you so much. I appreciate that again. I'm thrilled to be here. You guys are really the best. Thank you again for having me. The work I'm doing on the Math Library, is it similar? A little bit. I've studied object-oriented programming for a while now. My major now is IT, but for many years it was computer engineering and then electrical engineering. So I do have a strong background with programming. So it's similar in a sense because object-oriented concepts, they kind of apply across different languages sometimes. A little bit different syntax, that kind of thing, but it can still definitely feel familiar, I'll say. So in that sense, there's some similarity there. But beyond that, I don't know, not really. This has kind of been a new learning experience for me. It's kind of been a new learning experience for me. So I've had some pretty good success with it already. I feel confident about it and everything else, but I don't know. It's a little bit of both. It's a little similar, it's a little bit familiar, and it's also still a little new and fresh.
Mm-hmm. All right, great. It looks like we had a few more questions come in. Your presentations are really, really interesting for people. So take a peek at those, and while you do that, I'm going to look at the votes from your second poll. So the question was, considering the potential risks and the potential benefits of autonomous vehicles, would you personally be hesitant to use this new technology? And large numbers, so 16% say definitely hesitant, 44% say somewhat hesitant, 33% say not hesitant at all, and 5% are uncertain. So that's really interesting feedback. So let's look. So on the questions from the audience, we've got one here. Would you say future insurance premium calculations will be based on the age of the car, manufacturer, etc., as opposed to the age of the driver as is currently done?
That's a good question. I think it's both. I think that they will definitely factor in the age of the vehicle, the manufacturer. I also think they can even get more specific once these vehicles are controlling themselves. What version of the software do you have? Have we had issues with security flaws in previous versions? Did you get this patch? That kind of thing. The maintenance records of the vehicle even could be that much more tracked. When's the last time you got your oil changed? You know that sensor was beeping and told you. You know your light was on. I think it could calculate an even more in-depth assumption or calculation based on the vehicle itself and also the driver. Like I was saying, I want there to be, or I envision there being, individual-based behavioral calculation. So again, it's not just who's in your household. It's who scanned their fingerprint or who typed in their PIN or whatever it was, and then made the decision to make these riskier routes or to choose these riskier ways to go, or to take these back roads or maybe take manual override, that kind of thing. So I think that also matters there. Yeah, I think they'll do both of those things, and of course, age is a part of that as well. I think it'll be even more specific. I think that's the way it's going. We're going to have extremely, uberly, pun intended, uberly specific insurance-based calculations.
All right, Matt. Thank you so much, and we really appreciate you being our community speaker today. So
Thank you.
At this point, I'm going to go ahead and hand the reins over to Russ Whitehead, and Russ is going to be talking to us about developing a custom pluggable HPCC system security manager. So Russ, over to you.
Oh, thank you, Jessica, and it's going to be very hard to follow up on Matt's presentation. That was really interesting. But as Trish said, my name is Russ Whitehead. I worked with HPC Systems for 10 years, mostly on security, and I'm here to talk to you about security managers. But first, a quick poll item. I wanted to ask, have you developed or supported data security software in any manner in the past? We'll go over the results at the end of the presentation. So HPCC Systems has been designed with security in mind from the beginning, and there's a lot of different technologies that we utilize to make sure it is secure due to the sensitivity of customer data. Obviously, we recommend everyone put it behind a firewall, which will block external access to your HPCC systems. That will block out external things, but you still have risks and exposures from internally. So we allow you to configure many different features to make it more secure. HTTPS being one of those. That's for your browser traffic and SOAP calls that will encrypt, use public-private key encryption to send data back and forth to your browser. We also use transport layer security, which is also configurable, which is also public-private key encryption of your data between the components. So if you had someone trying to sniff on a socket in between components, even if they could see it, it would be encrypted. We have encryption algorithms that we use to encrypt data in transit, which is data being moved around between components on the wire, and also the data at rest, which is as data is stored on the physical media. If someone got hold of your drive, they still wouldn't, if you were utilizing data at rest, they wouldn't be able to see what it was. We use digital signature technology to make sure content is unchanged between the sender and the receiver. If someone sent a message that said, please give me 1 Bitcoin, and you changed it to say, give me 10 Bitcoins, so we would know with the digital signature that that was invalid, and we could reject it. Finally, the security manager, which is the topic here, that is a software component that HPCC Systems calls to authenticate users and more advanced features like feature-level authorization, which I'm going to talk about more later. But basically, you can authorize a user to have permission to utilize certain features of HPCC. For instance, give them write access to one file or read access to another file and so forth. So I'm going to talk some more about the security manager now. What is a security manager? It's a software library component provided by HPCC Systems that can be selected and configured by an HPCC system admin. It responds to security requests from HPCC Systems through a agreed-upon interface, which I'm going to talk about more. We provide several security managers out of the box, the most robust one being LDAP, which in addition to authentication, it also provides authorization to various resources. The more simpler one we provide, and I'm going to use as a reference model for the rest of this talk, is the HTPassword Security Manager. And that just accesses a Linux security password file to authenticate users. And once you're authenticated, then you have full access to the system. And these security managers are called by the various HPC systems components as needed to verify the users. So what is a pluggable security manager? That is a custom developed shared object library that supports our HPCC systems interface and it can be implemented by a third party and basically plugged into our framework. You might ask who would want to do that, what would be the purpose? Well, let's say you were considering HPCC systems for your company's big data, and because of the sensitivity of the data, your legal team or someone may say, I'm sorry, we don't know about these security managers provided by HPCC systems. We require to use our security. Well, in the past, that would have been it. If we didn't support it, then it wouldn't work. But with the Pluggable Security Manager framework, all you do is create a security manager that maps the requests from HPCC systems to your security manager. And that way, this can be done very quickly and easily, as I'll show you. Another possibility is that you're a vendor that develops a new security manager and you wanted to make it highly available to people out there, so you may just go ahead and develop a pluggable security manager for HPCC systems. And here I just listed some possibilities for some types of security managers you might want to implement yourself. Biometric, like fingerprint identification, speaker identification, retinal scans, embedded RFID microchips if your employer requires those, or multi-factor authentication, which is, you're familiar with that with a lot of your banking apps. You enter your username and password, and then they text you a code, and then you have to enter that into a box. So we're going to jump into how to create one now. Basically, as I said, we're going to use the HTPassword security manager as a reference model, and I'll be showing you some example code that we used doing it. But if you wanted to create your own, you could basically just copy this one and then go in and change the names and just start filling out functionality for the security manager that you want to support on the back end. But what we're going to be doing is you're going to create a C++ shared object library that supports the HPCC system security interface. The security interface is called ISEC Manager, and I'll show you that in a minute. You're also going to implement a factory function, which is when your library gets loaded by HPCC, we're going to call this factory method, which I'm going to talk more about, to create an instance of your security manager. And this allows you to have different versions of your security manager. Different factories could create different ones. Like you may have one that's authenticates with every request. Another one may cache results to be faster, and another one may have intense logging for troubleshooting. Who knows? And we create a base. We use inheritance to do this, to do most of the work for you. We created a base security class implementation that implements the security manager, and then all you have to do is override any of those methods that you want to customize, like obviously the authenticate method. You would override and do it the way your security manager wants, and then report the results back up. The other part to this is the configuration part. We have a tool called a configuration manager, and that lets you, among other things, select a security manager and bind it to the HPCC components. So you're going to create a little XSD file that basically describes what your security manager does and any attributes that are specific to that security manager. And the information from the configuration will be passed to your security manager when it gets created by HPCC systems. So you'll probably want to go full screen to see this. It's C++ code, and basically this is the contract between HPCC systems and the security manager. This is the language or the interface that we will use to communicate. Basically, these are all calls that HPCC systems will make to the security manager to authenticate a user, add a user, log out a session, so forth and so on. So this is ISEC Manager. It's a lot of functions you see in it. So what we did was implemented this thing called the Base Security Manager class, which are concrete implementations of all of those methods, and they don't do anything. They basically throw an error, but you would then override any of them that apply to you with your implementation. So this is the base security manager. And what we have here is the only thing your library needs to export is the factory methods that I talked about. At the very bottom you'll see create instance. That is called by HPCC systems to create your security manager and return it to us. And at the very bottom of this implementation file, you'll see that all that method does is creates an instance of your security manager class. And here at the top you'll see this is the class definition for your security manager, and it extends the base security manager. So right out of the box you have implemented all of the methods that are required for the ISAC manager interface. So here's an example of one where the authenticate call near the bottom, all it does is checks if the password is valid by calling this method up here. And this is HTPassword. All it does is it's opening a password file and comparing what the password the user gave with what's in the file. And if it succeeds, then they're authenticated. Here you could do whatever it is takes to call the security manager you're implementing on the back end, your biometric or whatever. And okay, so that's all there is to create your security manager. The other part, like I said, is configuring it. This is the part that's done by an administrator using our configuration manager. So the configuration manager interface is an XSD file which describes what information to display to the admin, what attributes you need to capture from them, things like, what is the library name of the shared object, what is the name you want to give to this, so forth. And it also describes how to write it out to our environment file, which is used by the various components when they're starting up to figure out how to load a security manager and bind to it. And I'm going to show you an example of it, but there's some obvious required fields: a friendly name, which you'll use in the bindings, the library name. This is the path and the name of the shared object file. You can have it anywhere on the file system that can be found by HPCC, and the instance factory name. I'll show you that a little more, but like I said earlier, you can have multiple factories to create instances of your security manager based on differences. Like I said before, one could do a lot of caching, one could do a lot of logging, one might be super strict. You have implemented a different factory to create each one, and that way, as I'll show you later, you can bind different components to different ones. And obviously anything unique to your security manager will be in that XSD file. So here's an example one. This is from our HTPassword, and these blocks show the various attributes that I'm going to show you in a minute in the configuration manager that you fill out, like the library name, as I just mentioned, to load. And the very first one, the HTPassword file, is unique to HTPassword. That's just pointing to the file that has the usernames and passwords in them. Our configuration manager tool, what you're going to do when you use it is to configure your security manager is first you're going to create an instance of your security component and fill out any attributes that are unique to it. Then you're going to bind it to HPCC components that need to do security-related things. I'm going to show you this in a second. Then you save that file and you deploy it and you restart the platform and your security manager is up and running. And what's going to happen is the component will load your shared object library into memory, and it will call the factory method that you specified to create it. And then from then on, it'll use the interface you return just to operate as normal, calling various security features. So here we have the configuration manager. On the left side, we list a bunch of the HPCC components. And if you right-click and do New Component, if you deployed your XSD file correctly, then you'll see at the bottom there, yours will show up. And like in this case, it's a HT password. So you'll select yours. And when you do that, the information from that XSD file you created previously will populate this table on the right-hand side. You should recognize those fields from the XSD file. And an administrator will fill all these out as appropriate, save the file, and that just creates an instance of the security manager. It's still not bound to any components. So in this slide, what we're doing is we're binding to ESP, which is our Enterprise Services Platform. The first thing you do is go into the Authenticate tab and tell it, yes, I want authentication, and I'm going to do it with a plugin. You then click on the ESP service bindings, and in here you can bind many different services to our ESP component. And on the three at the top, you'll see on the column near the far right, the security manager, the HT Password Security Manager plugin has been selected. Now in here you could pick different plugins for each different service. Like for instance, let's say WSSQL, you wanted to be authenticated every single time, no matter what. Or on another one, you might want to use a caching version of your security manager. So this just allows you the flexibility of that. So that's basically all there is to it. Here's some ideas of different things you can do to supercharge your pluggable security manager. As I mentioned before, caching will speed up access for the active users, but there's the possibility that if you change a password or they deactivate a user, then the cache, you'd have to wait for the cache to clear out before that takes effect. Logging is something that we find very helpful. It lets our users and the admins find out what's going on, debugging problems before they have to come to development to do it. Auditing is a big thing. If you have an auditing committee that wants to manage, what users have done, what kind of activities, what type of resources they're utilizing, you could add that to your security manager. And blacklisting and whitelisting, which is just restricting certain and allowing given domains. And that's basically all there is to it. I had to create one of these. I was testing a possibility for another security manager type, and I'd say within less than 2 hours I had it up and running. I mean, it's really is straightforward. Obviously, I've been working on it, so I was a little bit quicker, but here's some useful resources to help you along. Our HPCC Systems website is really useful. We've got white papers there. We have all of our documentation. You can download virtual machines. There's a community forum where you can post questions, and the HPCC Systems developers will respond and research problems or issues that you're having, or you can just search it for, maybe someone else has had the same issue as you. The HPC Systems platform is open source. Anyone who wants to download it and contribute is welcome to. Here's the link to it on a repository called GitHub. We encourage people to contribute. And if you're interested in looking at the security model reference platform, here's a link to the HT password one, which is in GitHub. And like I said before, you just copy it and start filling it out. And of course, you can contact me if you have any types of specific questions related to security. I'd be happy to hear from you. So to wrap it up, we're going to have another poll, and I just want to know if anyone out there has been a victim of identity theft themselves, and if so, were you damaged by the information that was stolen from you? And Jessica, back to you.
All right. Thank you, Russ. All right. So I'll give you a second to look through the questions, Russ, and while you do that, I'm going to look at the results of your first poll. So the question was, have you developed or supported data security software? So 16% say yes, and 83% no. Say no. So I'm hoping that this presentation has given you something to work with. Security obviously is very important to all of us, and Russ, you did an excellent job explaining all of that for us. Thank you.
You're welcome.
All right. So looking at the questions, So the first one we have here, can ESP be configured to use one security manager and Dolly configured to use another?
Absolutely. This is one of the things that we planned for as we designed it. Not only can ESP use one and Dolly use another, those are just two HPCC components. As I showed in the example, ESP can be configured to use different ones. Like I said, if you have different security requirements for the different services within ESP, then absolutely, you can.
Okay. It looks like we have another question. It looks like it's fairly similar to that one. Can a custom pluggable security manager be used by components other than ESP, such as Dolly?
Yeah, yes, absolutely. There's at least one other component I can think of, ECLCC server, that utilizes security, and I'm sure there are more I just can't think of right now. But yes, they all can.
All right, wonderful. Can you restrict access to the landing zone folders, work units, and file scopes using the security manager?
Yes, you can, and that's one of the advanced topics that our LDAP server security manager does. The HTPassword one, as I said earlier, all it does is authenticates you, and once you're authenticated, you can do everything. With LDAP or any more robust security manager you want to implement, then you create what's called features. You just give a feature a name, like a file spray or landing zone, and then you can assign users or groups permissions to read it, to write it, to delete it, and so forth and so on. So yes, through the ISEC Manager interface I described earlier, you can do all of these things.
All right, perfect. So it looks like we have one more question. If anyone else has any additional questions, please go ahead and send them in. So right now, this is our last question. How does an administrator configure feature-level permissions when using their custom pluggable security manager?
Okay, so if your custom security manager does support feature-level authorization, then the administrator is going to use the same interface that he does currently. That would be going into the system, the security tab of ECL Watch, which is our management console, and in there's sections where you can create groups, add users to the groups, and then assign various permissions to those groups to restrict or allow access to resources. And regardless of what the security manager you have configured, the interface for the administrator to do that is always the same.
All right, perfect. Thank you. And just to note that in the attachments and links section, there is a link to the HTPassword reference model source code. And you can also download this presentation so that you can get some of those links from Russ. So before we move on to our next speaker, I want to go back and look at the results of your second poll, Russ. And the question was, have you ever been the victim of identity theft? And if so, were you somehow damaged by the information that was stolen? And 90% of our respondents say that they've never been a victim, which is great. 9% say that they have had their identity stolen and it was used in a manner that damaged them. So I think we're fortunate on this phone call, our participants, that 90% have not been a victim. But it sounds like the 10% that have been, it's not been a good situation for them. So we're sorry to hear that.
Yeah, that's interesting. I thought that the statistics would have been different, but interesting.
Yeah,
well, thank you.
Yeah, it's really interesting.
Thank you very much for giving me the opportunity to talk to you guys.
All right, and Russ, thank you so much for coming, because I know this came up at a previous Tech Talk, and we appreciate you being willing to come and speak to us today. All right, so Craig, you are our next speaker, and we'll be talking about the work unit graphing feature of the ECL Watch. And Craig, thank you for pinch hitting for us today and doing this tip. And I'll turn it over to you.
Thanks, Jessica. It's really nice to be here with you guys this morning. As was stated earlier, I'm your substitute teacher today for Richard Taylor and Bob Foreman, who are out on assignment. So today, what they had asked me to do was look over the ECL Watch graphing features, because they've had several questions and they wanted to put together a little more formal for it. So this is kind of our first whack at it. So what one of the first questions I want to ask you guys is, are you using the ECL Watch graphing functionality? Do you use that as part of your daily work or any time that you're coding in ECL? So I imagine we'll come back to that in a bit. So our goals for today, we want to, first, there's an assumption that I'm going to make that you've been using ECL or you've at least seen the ECL Watch and can move around in it okay. So what I'm going to do is take a look. We're going to start with a work unit. We're going to look at how we drill down and try to find the graphing feature itself, and then begin to look at a job and begin to examine our work unit using the graphing feature itself. I am going to try to switch back and forth to a live display. I've got a job that I ran yesterday on one of our development Thor clusters, so I do want to try to switch back and forth. Hopefully that's going to be smooth for us today. So the first thing, if you really haven't explored an ECL work unit before, there's just a wealth of information. There's a lot of beautiful things that you can find, probably more information than you ever imagined if you haven't really poked around before. So there's a great deal that you can use in order to see that your job has functioned properly, or if it's malfunctioning, you've got a problem, something's not going right, you're not getting the results you expected, you can use the work unit to help try to discover what issues you might be having. So this is just a work unit. I imagine many of us have seen this before, and I'm going to try to switch over to my screen. And when I come into the ECL Watch, of course, we're going to come to the cluster itself. And one of the first things I want to do, you can find your work unit in many different ways. If you haven't had to do this before, you can use the search feature, which we see in the upper side. If I've given a work unit, in fact, here at Lexus, we tend to use work unit numbers as part of our conversation in order to be able to view various jobs and do inspections. So in this case, I've filtered down my job results to things that I've run recently. And what I can do is select a work unit that I want to take a look at, and it'll take me to the work unit details, like I showed before. We can get what the name is, when it was run, various aspects of it. There's a lot of information available to us. There are many tabs available. And today what we're going to do is focus just on the graphing tab itself. So the first thing that we're going to look at, once I've selected a particular job and I want to take a look at what its results were, there we go. I can go directly to the graphing tab, and the first thing it's going to show me, this is an overview of the entire work unit. So it's going to show how many graphs the work unit itself was broken into. What the ECL compiler is going to do is take a look at your job, look at the complexity of it, and look at what things it may be able to do in parallel, what things are going to have to be done sequentially, and break the job into various sub-jobs, which for us become individual graphs. So we can look at various aspects of what has happened, and you'll see that your jobs are going to get broken up for various reasons, possibly external calls for SOAP calls, or you may have a persist, which is a great way to break a graph if you want to forcefully break your job into several graphs. And today what we're going to look at, so what I've got on the left-hand side, all these are live links on the far left. These will get me to the individual graphs. What it's not going to show me is every graph displayed all at once. So essentially my job is going to get broken down into these graphs, and I can look at these individually. So I've got various statistics as well. It's going to show me the order in which the graphs are going to be executed. It's also going to show me what the various durations and start-stop duration times. So I can also take a look at that to get an idea of where the work unit itself was doing the most work, where my most expensive portion of the job might be. So on the right-hand side, it shows me this nice tree view control or tree map control. And it does it, we look at this as a heat map to say, or the graphing system itself is trying to tell us where we're spending most of our time. Now, one thing to keep in mind when we do look at this heat map on the right-hand side is relative to the entire job itself. Now, you're going to pop one of these open, and you're going to see, oh my gosh, I've got a great big red square. Maybe I have a problem there. But take a look at the statistics of it itself, and every one of these jobs is going to have a big red square, and it's going to have at least one portion of the job that takes up most of the time. Even if it's a single graph, it's going to be one big red square. So it doesn't necessarily indicate that you've got an issue. However, it does try to highlight where most of the work is being done. So I'm going to go ahead and select a graph. Excuse me. So what we want to do, once again, I've kind of explained what we've got on the right and left-hand side. And one thing that's also very interesting about the jobs is as the job is executing, as soon as you have submitted a job, a work unit is created. Even before the job has started to execute, you've got various information that you can look at, and you can even see what graphs have been decided by the ECL compiler. So you can start inspecting this job even as it executes. You don't have to wait till it's finished executing. So one of the things that's also available to you as it does execute, and you'll see down the left-hand side, hopefully if you can see on your resolution, you'll see that I've got little green marks on each of these graphs telling me that they have completed successfully. You may see that only some of them have completed. Your job is probably in execution at that time. But I can inspect graphs that are completed even before the job itself has completed. Now, it's going to show you what has currently been brought down from the server at this point. So over a period of time, maybe a few minutes have gone by, and I think my job has probably progressed a little bit more. I'll go ahead and hit the refresh button, and that will bring down fresh information as the job stands at that very moment. So now I can start going into the graph itself. So in this case, I went ahead and picked the graph that had the most red on the heat map, so I could go ahead and inspect that. And what it's going to do is show me what various subgraphs I have if I want to focus on various portions of the job itself. But in this case, it's going to show me the entire graph, and it's going to show on the right-hand side, it will give the graphical illustration of what my job is, and it also gives me a really nice flow of data. So there's a lot of information I can get from here. Now, one thing that you notice I'm doing, I can drag and I can drop. I can zoom. I can take a look at these. If I want to pick a custom zoom, I can come to the top and I can say maybe I want to go to, say, 200%. And I can still drag that around and I can inspect various activities and edges. And once again, what we're seeing here, the graphs themselves are broken down essentially into two major objects. We can look at the squares, which are the activities, essentially the ECL code, the commands and functions that we're using. And of course, there's little icons over each of these activities to try to give a little bit more of a graphical display of what they're accomplishing. Plus, they're obviously tagged, telling what these activities are. So I can see the activities, and then the connections between the activities are the edges. So the edges themselves show us the flow of data between the various activities. These are very important. In fact, when I'm working with ECL, it's the edges that I look at more often than anything else. So each of these items I can take a look at, I can inspect, and in fact, what I can do is I can tunnel down directly onto an individual activity if I choose to. So for instance, if I wanted to see this distribute command that I used, I can click on that, and then what I'll see is I get this great back and forth interactivity in the graph. So on the graphical side, if I choose an activity, on the left-hand side, in an expandable window, I can see all the various technical aspects for the execution of that distribution or that activity in this case. So it's going to show me what the line of ECL code was, at least insofar as how the compiler sees it. It's going to show me some of the statistics of how it executed and how the various nodes of the system are handling it. If I want to, then I can also click on an edge, and it's going to show me some of the statistics for the edge. Once again, how the nodes are reacting to it, how many nodes are on average, what node did less, what node did more, what the average was for the various nodes. So once again, one of the beautiful things about the ECL language is that it tends to abstract the highly parallel nature of the system itself. However, we know as developers that we do have to pay close attention, that we have a number of nodes that need to work together as well as possible. And the graphs will help us understand whether that's happening as we expected or not. So I'll look at that in a little bit more detail a little bit later. Sorry, I'm kind of outrunning my slides here. So we can take a look at the various aspects of our job. We can tunnel down, we can move back and forth, and we can see various things that we do that. So one of the things that we're going to look at is how this interaction between the activities and edges takes place, and what we can find out about it in our graphs. Now, this slide tells us that we can look at these graphs in various aspects. The default mode of viewing is the tree view mode, which we see all of our graphs. We can tunnel down into the graphs. We can see the subgraphs. So we look at it more from a graphs perspective. However, if I choose to, and we have various icons that we'll see in the upper left-hand corner of the graphing tab itself, we can see that we can start to look at our job from different aspects. So I'll go back to my view here, and I see these various icons. So we can see it in the subgraph mode, that's the default mode, but we can also look at it purely from an activity mode. And these panels can be open, they can be contracted, expanded, we can do that. Now what I can do in this case, instead of looking at it from the graphical perspective on the right, I can look at it more of a tabular sort of a form and see all of the various activities that I have going on in this graph itself. Now, each of these columns are going to give me a wealth of information about statistics that I can see various timings, node participation, something called skew, which we'll talk about here in a minute, the amount of data that I see going through these types of things. So there's so much information. Now, what we do see on the right-hand side, or at least in this tabular view, we see every single attribute that is supported by any activity. However, if I highlight a particular activity, if I highlight an activity, what will happen on the right-hand side, the graph will constrict its view just to that activity and its neighboring activities. By default, it's going to show 2 activities before or prior and what will succeed it. I can expand that or I can contract that. One of the things that I have available to me is this relative distance. If I say I want to see activities, 3 activities from the highlighted activity, I can expand that. If I want to try to contract that, I can bring that number down, and I can say I only want to see the prior and subsequent activities to the one that I'm looking at. Also, when I select an activity, what I'll see below it, I will see every attribute or every piece of data for that particular activity that has some actual data. Because when I look at it up here in the graphical or in the tabular view, I'll see that I have several null columns or empty columns. So if I highlight that, it will only show me the columns that have some data that I can look at. So that's a nice, more focused view when I want to take a look at these. So once again, I can select any of the particular activities, and it will regraph around that, or on the graph side, I can pick an activity there, and once again, it will be fully interactive back and forth. Something else that you'll see that I failed to mention is if we have a slightly restricted tabular view. If I want to see a somewhat larger view, I want to really expand this to full screen. Up in the upper right-hand corner up here, you'll see that I have a little open a new page. And what I can do is open my own page just for this graph. And then I can see that hopefully in a little bit better detail, depending on the size of monitor that you're working with or what you want to do. But I can always go ahead and zoom or not zoom. Some of these graphs can be really massive, so you certainly want to use all the real estate that you have available to you to be able to move around. So let me go back, see where we're at. Right, so we've got these other views. So I can go to the activities view. I can also look at it in the edges view, right? We've got these 2 major components that we can pay attention to, the activities and the edges. And I can go and I can see in a tabular view all the edges that I have. I can select various edges. It will once again highlight it on the graphical side, and it will give me all of the pertinent data or all of the populated data that I have for that particular edge to be able to inspect it. Another view that I have, the next one, I can go back to the tree view. I can see more or less the default view, and I can look at the subgraphs, and I can see what I have available to me in those. Now the last 2 that I have available are the tree map or the heat map views. So I can look at a heat map for the activities, and it's going to show me, or rather for the graphs themselves, right? This is the timings that I have that's going to show the timings for the various subgraphs. I can also look at the activities heat map. So this is going to, in a nice graphical format, show me the various expenses that I've kind of used up in my work unit in order to get this particular graph through. It's going to show me what the more expensive portions were. So for instance, I can look at that activity and expand that out a little bit, and I can see where that falls in my process, and I can see in this case that took quite a bit of time. In this case, the reason, and this is where you want to begin looking at your graphs to say, okay, why was that the most expensive thing that I had? In this case, when I look at it, I can look very very closely at the edge immediately preceding the process, and I can see that it had to process 4.9 billion records. Okay, so that's going to take a little bit of time. So when you start to look at it, you need to look at why did something execute quickly, why did something execute rather slowly in a relative manner. And I can see oftentimes it's going to be very high record counts. It may be a very expensive process that you're doing as well. So that's what you want to look at, and look at some of those timings in order to find possible efficiencies or to be able to explain things that you're seeing that may be delaying the job. Excuse me. But once again, what you're seeing, this is relative to the graph itself. So the expense of it, in this case, my average execute time, my average execute time was just 0.31 seconds. So it wasn't all that terribly expensive to begin with. So once again, our little slideshow, and once again, this will be for you to have going forward to do that. I'm trying to do this more in a live display. Excuse me. So we've got the various activities that we can look at, or various aspects that we can look at it. Once again, going back and forth between the graph, trying to inspect and see everything that we have. If I want to go back to the full layout, once again, I can go back to the tree and select the root of the graph itself, and I can see everything here. Be careful. Sometimes the graph is going to be so complex that the interface won't allow it to be displayed and will force you to go down into subgraphs. If something has hundreds and hundreds of activities, which is very likely or very possible, you may see that, so you'll have to tunnel down into the subgraphs. I chose not to grab one that complex today. Excuse me. When you're looking at the graph, some of the things that I'm looking for is I'm generally looking at the edges. In fact, when I'm working with my supervisor, the first thing he wants to see is let's look at the edges. Let's see what the record counts were. Let's see if we've got anything that looks anomalous in what we're seeing. So I'm looking for, oftentimes if I see an activity and I've got a 0 record count for it, I need to inspect that. I need to find out if that's what I was choosing, then that's great. However, if I'm getting 0 record counts when I expected to get some records, such as maybe a filter that wasn't working right, or some other, or a join condition that didn't really join the records properly, or I didn't have the records distributed such that the join would execute as I expected. So those are the things that I'm going to look for as well. Those are very important to us. Also, if I look at the edges, we'll see something called skew. All right, so the skew, and I'm going to go back to my job. So as I read the data, this was coming off the logical file, and I read 4.9 billion records. And the skew is what I see as the plus and minus. In fact, what this is trying to tell me is the relative participation of the nodes. When I see that a large number of nodes are doing most of the work, or maybe a small number of nodes doing the work, or I've got nodes that are doing no work whatsoever, what I'm going to see is skew. In other words, it's trying to tell me, are the nodes cooperating together? And the closer I can get to 0 on skew, that's what I'm going for. So you'll see a positive skew and a negative skew. Positive skew telling me that I've got nodes that are participating more than other nodes, and the negative skew telling me that I've got nodes that are participating less than other nodes. In this case, the skew looks really good, and that's because the data has been very effectively distributed across the nodes. In this case, I'm running on a 400-way Thor. So that's showing me quite a bit. Now, as I come down, I'm going to see something change a little bit. I've got a filter where I peel off from that 4.9 billion. I peel off about 500 or half a million records. And now I see the skew tend to go up. And that's what's going to happen. The smaller data sets you have on these large clusters, you're going to see the skew go up naturally because the distribution that you have generally isn't always going to be perfect. Right? Over very large data sets, you're going to see the skew, or you're going to see the distribution average out really well. But on the smaller sets, the distribution isn't always going to be as pristine as you might like. So that's where I'm going to see. But once again, the skew was pretty much within tolerances. There's also something that happens on your cluster. Based on how the setup of your cluster is, if the cluster detects the skew in your job going above a predetermined threshold, the cluster itself has the option of aborting your job. So the cluster is watching skew too. That's very important because we don't want to have just one node doing all the work or just a few nodes doing all the work because of the efficiencies that we lose. Remember, we're in a highly parallel environment, so we want to get as much work out of every node as possible on every job. So we definitely want to watch the skew. In my own experience, probably our best weapon against skew is distribution, or using the distribute function, making sure that we have our records somewhat randomly scattered across all the nodes so that every node can participate in it in a as close to equal manner as possible. So here's my last slide, and this is where I'm taking a look at the skew. And the skew percentages that you're going to see, or these numbers that you're going to see, they're based on the number of nodes you have on the particular cluster that you're working on. In the example that I have on the right-hand side, we're looking at the skew, we're looking at the minimum and the maximum skew, and this one in particular is based on a 10-node Thor. So if you look at the graphic to the upper right, you'll see that it has a plus 900 or 9,000% skew in this case, meaning that in that 10-node cluster, I've got one node that's doing all the work. In other words, I've got essentially all the other nodes are doing nothing, or all the other 9 nodes aren't doing any work at all. And the minimum skew that we see on the right-hand side is not going to go beyond minus 100. That means you have at least one node that is doing no work whatsoever. Now, in this case, in the demonstration that I was able to create that, this was for a very, very small data set. And the data set itself, was just maybe 50 or 60 records. It became kind of a lookup data set that I had to go against a much larger data set. And in this case, all of the records were clustered onto a single node. So you do want to look for that, and if you're seeing this kind of, you're seeing skew with very high numbers on larger data sets, then you have to really carefully evaluate the distribution that you have. So you want to look at that carefully. So like I'd said, the skew percentages that you see on the left-hand side are completely dependent on the number of nodes that you have. For instance, on that 400-way Thor, I could see, in this case, 40,000 if I had just a single node of that. In our particular situation, that job would have been aborted if I see that kind of skew. Also, you may see some skew. I've done distributions, and you'll have distributions over a large set, and you'll come down to a very small set. Well, though, the portions of that set will be distributed across the nodes, and you'll see that if you don't have enough sets to go across all the nodes, you'll see the distribution skew very heavily. So that has to be watched as well. In some cases, your work unit may be aborted, or if you know that you're going to have a very high skew on a small amount of data, you can, depending on the command, you can tell the cluster to ignore the skew problems and tell it you still want the data and still move through. Excuse me. Okay, so that's kind of the end of going through graphs. And the last question I wanted to ask you then was, have you ever actually used the graphs in order to solve some sort of a problem that you might have? So with that, I'll hand it back to Jessica.
All right, Craig, thank you so much. That was a great overview, and I just feel like that's so powerful, the graphing functionality. So, all right, while you take a moment to look at the questions that have come in from the audience, I'm going to go ahead and go back to the results of your first poll. So the question was, do you use ECL Watch graphing functionality? And it's an even split, yes and no, 50-50 each. So that's pretty interesting. So hopefully for the 50% that haven't used it yet, I hope that you've picked up something that you can use today. All right, I'm going to go ahead and go to the questions. This is a wonderful time. If you haven't submitted a question and you have one, go ahead and put it through for us. All right, so the first question we have here is what you commonly look for in the graph.
So that's a good one, I tried to address that a little bit when I was speaking. The very first thing I'm looking for is the edges. I'm really looking at record counts. I have, in the jobs that I work with, I certainly base a lot of expectations on the record counts that I have, whether it's from the base data set that I'm working against, or maybe it's some type of foreign data set, and maybe I need to do a join and I have to have some expectations. Generally, that's the first thing I'm looking for. If I see a job is running really long, I'm also going to be watching very carefully for skew. It's another thing that I'm going to look for is how many graphs did my job get broken into? Or did it get broken into additional jobs as well? Is it something that's not getting the amount of parallelism that I would rather prefer. If I've got a single graph, I'm not going to get too much parallel activity for various jobs. So I also want to take a look at the ECL that I have to see if various segments of it can be forced into parallel, or if I can break graphs such that that type of thing might happen.
Okay. It looks like we might have a few more questions, Craig. All right. Here's another one. Is there a legend to describe what each of the icons are in the graph?
And I don't have an answer for that, but I wanted to pick that one. No, I don't. And in fact, what you should use is the label on the activity itself. The label is very descriptive, and I think the icon is just there as a visual aid, but the label on the activity itself is what you want to look at.
All right. Let's see. How does skew affect my work unit?
Skew can affect your work unit in a couple of different ways. If you've got a heavy skew, that means you've got fewer nodes participating, and subsequently your job is going to take longer. If you've got fewer hands pushing the bus, it's just not going to go as well. Skew can also affect, and skew has affected me probably most profoundly in that when I have a heavy skew and the cluster aborts my work unit. So you do want to look at that and evaluate carefully why you've got the skew. Generally, it's going to be your data. You want to look at the data, and if you run into a position where you see a heavy skew, take a look at the distribution, find out whether you've got just one or two nodes participating. For instance, if I had a data set that was sprayed onto a cluster, and maybe the data set came in say zip code order, for instance, and I didn't distribute it otherwise, and maybe I did a query that said I want to see something from California. Well, all the California records are going to be on a very small number of nodes because of the way that they were sprayed onto the cluster. So then I'm going to have very, very heavy skew, and I'm only going to have one or two or maybe three nodes that are participating in the query. So it's subsequently, I'm throwing away the power of HPCC when I do that. So once again, distributing your data, it's not that terribly expensive. It's been optimized fairly well from what I can tell. And it will definitely ensure that you can get as many nodes participating in your queries as possible.
All right. So our next question is, does one browser display the graphs better than another? What about the version of the browser, and are there any other plugins required to view the graphs?
No, you don't need any plugins. I personally, I use two browsers myself. I use Chrome and I use IE depending on, I guess, my mood during the day. I have not used Firefox. However, in the discussions that I have with other developers, I have not heard any real issues between browsers. And of course, none of them need plugins. This is all native to the browser itself.
All right, great. Here's one more question. Why are there multiple graphs for just one work unit?
That's at the behest of the compiler itself. The compiler is going to take a look at the job and see if it can do any optimizations itself by breaking the job into several subunits. And each of the subunits that the compiler decides on, those become the graphs itself. So the compiler may or may not decide to break up your job. There are certain aspects or certain commands or functions you're going to use in the course of a job that are going to force the compiler to break it apart. But if the compiler doesn't feel like it, it's not going to. So once again, it's the compiler that makes those decisions.
All right, great. Thank you. So I'm going to go ahead and read the results of the last poll. If anyone has any additional questions, go ahead and send those in. And Craig, I'll let you watch those while I read the votes from the audience. So your last poll question, okay, so here's our last poll question. Have you ever used the ECL Watch graphs to solve a coding issue? And again, we're split exactly 50-50. So again, hopefully those of you who haven't done this yet have learned a new skill, a new tool that you can utilize as you look into coding issues. All right, it looks like one last question has come in from our audience, so we'll go ahead and ask this one. How are the graphs different if you're looking at the graph for a Roxy query versus a Thor job?
I wish I could answer that. One of the things that in my introduction, I've been developing for over 25 years, but I'm relatively new to ECL, and my experience is purely on the Thor side. So I'm really sorry I can't answer that one.
You know what? We will go out and we'll see if we can find somebody who can answer that. So for the person who asked that question, I'll do a little searching internally here and see if I can get an answer and send it out to you. All right, wonderful. Craig, thank you so much. We know that you're pinch hitting here, and you have done an outstanding job. So thank you so much for that.
Thank you all very much.
Yeah, thank you. So submit a talk for an upcoming episode. So, you know, we've got Russ, who came in as a result of somebody asking a question. We've got Craig pinch hitting. We've got Matt, who's an intern here. We've got all sorts of people coming and presenting, and we know that you have a wonderful story to share with us. So if you've got a success story or a new use case, we would really like to hear from you. If you have a new application that you want to demo, or some tips or some sample code, or even a suggestion for the roadmap, please do reach out to us. You can be a featured speaker, or you can just reach out to us with a question at techtalks@hpccsystems.com. And definitely visit the Download Tech Talks wiki for more information. Also, please mark your calendar for the May 17th Tech Talk. And we're already lining up some excellent speakers. They're not confirmed yet, so I don't want to say anything. But we've got some great things coming up on May 17th, so watch for that. And also watch out for our events on the events page of our website. We've got all sorts of things coming up. We've got Arjuna and Flavio are presenting at a meetup coming up in December, or excuse me, not December, on Tuesday. And the week after, Arjuna will be presenting at the Open Data Science Conference, so ODSC in Boston, and Bob and I will be staffing the table there. We would absolutely love to see you. We've got C-Day coming up at Kennesaw State University, and all sorts of exciting things. So please watch for that. We'll also have a customer use case webcast coming up shortly that should be posted sometime within the next week, and that'll be happening on May 22nd. So lots of great things happening for our community, and we hope that you'll stay involved. Thank you so much for joining us today, and we'll look forward to hearing from all of you again in May.